All right, let's get started. Let me introduce myself. My name is Ming Zhang. I'm in Houston, Texas. My background is math and computer science. I worked in the past 25 years as a mathematician and computer scientist, mainly on algorithm development and implementation. And in the past 10 years, I've been working with all the competitions in math, physics, computer science. And in the past 5-6 years, I focused mainly on the USACO, USA Computing Olympiad. And everybody in this class should already know this contest. In terms of the style, USACO is probably the closest to the IMO style. So in IMO, you have 3 questions and you need to finish within 4.5 hours for each day, and there are 2 days. And for USACO, that's similar. You have 3 questions and you are given 4 hours. USACO in March round, each year there are 4 rounds. In March round, actually you have 5 hours to finish the 3 questions. So different from other competitions, even MC10, MC12, AIME, right? Where you have to finish more problems in a short time period. So here, if you get stuck in a question, don't feel frustrated. It is common. It is actually very common. I would say it is almost impossible. You're going to see how to solve the question within, say, 2 minutes or within 3 minutes, right? That's almost impossible. So if you spend 30 minutes without any idea, that's common. Spend 1 hour, still don't know what to do, that's still common. And along the way, you can feel many times in the 4-hour period. In the first 2 hours, checked question 1, question 2, question 3, still no idea what to do. 3 hours have passed, well, not sure what to do. But by the time 3.5 hours, I think I got an idea what to do with question 1, and then took you, say, 10 minutes to write the code. And as you were working on that one, and yeah, I think question 2 it should be solved this way. And then within 10 minutes, you solved question 2. And then the last minute, you thought, yeah, question 3 is doable. Even though I don't have a perfect solution, I can solve 9 out of the 10 cases or 5 out of the 10 cases. Voila, you submitted, and then you passed the contest. So that's common. All right, so the idea I want to put at the very beginning, don't feel frustrated, don't feel scared in the contest, also in the practice. Many parents have told me, my student has spent the past 2 days working on one question and behaved in a very strange way. Do I have to worry about it? Normally I say no. That's a good sign. Your student is making great progress, because you have to learn from the frustration. You have to learn from the mistake. You have to learn from the bugs. Okay, so I'm going to share my screen and we're going to get started. By the way, in the bronze class and actually in the silver class, we're going to use Java. And from gold and above, platinum, we're going to do Java as well as C++. Either one would be good. And actually, we're going to ask students to be good at both languages. Besides Java and C++, I do not actually recommend, even though Python is very popular. But for USACO, Python still is not a very good choice. Why? Python sometimes still too slow. So you know the restriction for each case, right? For C++, each case you have 2 seconds to finish the execution. For Java and Python, each case we have 4 seconds. So Java is about half of the speed, sometimes a little bit faster. So that's pretty fair. But Python sometimes still slower than Java. So for some questions, no matter how fast you run your code, you write your code, implement it, still you cannot finish the execution. That's why the number of people using Python is still much smaller than the other 2 languages. And in higher level, it's almost not seen there. I mean, Python users. Okay, today we're going to do the, from the announcement, you know, right? We're going to talk about arrays, access elements and neighbors in rows, columns, and the diagonals of actually arrays. Before we can do arrays, we have to create an array. So I'm going to open my Eclipse. By the way, for Eclipse, the reason I pick Eclipse over other IDEs, interactive development environment, is because Eclipse is lightweighted. Actually, from your experience, if you are using Eclipse, when you install Eclipse, actually you don't need admin privilege. Of course, right, if you want to install JDK or JRE, you do need admin password. But for Eclipse, you don't. And JRE is not just used by Eclipse. Actually, many of the programs or apps on your computer now do require JRE. So when you install your computer, when you buy the computer, right, actually JRE most frequently would be there already for you. So just download the Eclipse. How do you download? Google Eclipse Java, and then normally you're going to be directed to the download page. When you download, you're going to run the installer, and that is this. Once you install, you're going to have the Eclipse. I just updated my version, the June version of Eclipse, 2020 June version here. So if you have it, it will be something like this. Actually, once you install Eclipse, the first time you run it, you're going to have this page here, the welcome page. And you're welcome to read some of the pages, especially the tutorials. Very good. There is a question. Stephen asked, is Eclipse supported in Mac? Yes. No wonder it is actually the most important platform for Java developers. Okay. We don't need this one here normally, right? Just say I'll close this one, and then you'll be you have this page. Actually, let me change this one. So once you start, you can have a page like this. This is the part for the project list. And this part, the middle, is the editor. Once you type the code, the source code will be here. This is the task list. Actually, we don't need it. For USACO, you can minimize it. Outline, you can minimize. Okay, so you have a big space for the editor. And then this part is for the console. Okay, you don't see the console, that's fine. Show view and the console, and it will be here. This is the output. For USACO, there is no graphics. Okay, GUI is not touched at all in USACO. So you don't need to worry about, okay, how do I pop up window to show the shape, to do the animation? No, does not have anything to do with that one. So very likely you're going to see the output. The output will be almost all the time would be just a very simple number or some numbers. Okay, so for debugging purpose, you're going to run the program and see the output. The output would take a small part, a small area of this window. All right, so for recording, I think I've started recording. Give me 1 second, double check. I am recording this one here, so. Okay, so let's see. If I want to use an array, I have to first create an array. So I'm going to do this one, create a class here. So by the way, right, array is a keyword. So do not create a class array. If you want to use it, right, you can use array1. Of course, right, if you say lowercase a, that's fine. And then check public static void main, and hope these you have done already. Of course, right, if you've done Java programming using another IDE, that's fine. Actually, before I switched to Eclipse, I was using NetBeans for a long time. NetBeans is also user-friendly, but it is heavier. That means when you install it, it does have all the GUI part associated with it. So if you don't want to use it, it will be a little bit heavier than necessary. So Eclipse is just ideal for USACO. Okay, so here if I want to create an array, that's easy, right? Define, say A is an integer array. So the difference between a variable of integer and a variable of integer array is the difference between the pair of the brackets. So the brackets will indicate A is an array rather than just one variable. Okay, here. You can also declare this one using, declare the size here, say 10. So this will declare an array of size 10. So this asks the operating system, please give me a chunk of space in the memory that will be big enough to hold 10 integers. So these 10 integers will be stored physically next to each other. Actually, in Java class, you have heard the advantage of using an array is the elements are stored physically next to each other. Here, when I say physically, they are actually physically there. You say everything is electronic, but they're still physically there. Since the numbers are next to each other, so it takes less time to access them. So compared with other data structures, this one has the smallest access time. So arrays have been the most fundamental data structure in pretty much every programming language. So you can use Java, you can use C++, you can do Python, you can do Pascal, Fortran, all these languages, right? Without exception, array would be the first data structure you're gonna learn. All right, so here in Java, if an array is declared, the default value would be 0. You can display here, if I want to display j0, j less than a dot length, j plus plus. If I want to display every element, I can do this. A dot length actually would be better than using 10, because later if you change the size, you don't have to change this value here. So a dot length would be a byproduct to find out the number of the elements in the array. Okay, so if I run this one, I'm going to have 10 copies of 0. Okay, I can change the shape. So you can make this one wider, narrow. You can make this one taller or shorter. Okay, so there are 10 copies of A. So by default, an integer array in Java is initialized to 0. So that's how you access the elements in an array using the bracket operator. So normally we say there are 5 basic operators: plus, minus, times, divides, and modulo. But sometimes we call the 6th operator, that's the bracket operator. So use this one, you can access the element in an array. So this is good for an array, right? Suppose I have 1 million elements in the array. I can just use a bracket 0 all the way through 999,999. I don't have to create 1 million variables. That'll be awkward. All right, so that's how to create an array and how to access it. And of course, right, in Java, you can also do this one. Actually, this is the same for Java and C++. You can also say int, say b equals, just do this one here, 1, 5, 2, 4, 10, and so on. This will also create an array and also initialize it. Okay, so this command at 912, it's a combination of the declaration and also initialization. And sometimes you can see we can do this, c equals new int, and then 3, 6, 10, 20, and so on like this. Both are fine. All right, so don't feel surprised, right? Sometimes you read the code, you see, okay, I understand this one here. And what does this do? Well, actually, it's the same thing. One word I want to put here, actually, Java is a strong typed language. int actually is not a Java class. The complete class actually is called integer. So actually, when you define a variable, say int x or int array a here, right? Actually, Java will actually convert into, so this int x equals 5. What Java actually does is this one, integer x equals new integer 5. The reason we still have the int x equals 5 is to provide compatibility. For old programs written in C, C++, right, we have a lot of those statements, int. So to provide compatibility, we still allow the int x equals 5 in Java, but actually it is this one here. So we're going to create a class, I mean, an object of the class integer. And actually you have seen many times, right, when you do the programming, you say integer dot max value. And many times you would ask, right, what is this integer dot max? Why can I use the int dot, right? No, I can just say print. Of course, right, this would be the value 2.1 billion. Run it, you can see the 2.1 billion. Actually, this is 2 to the power of 31st minus 1. And then the minimum value would be the negative 2.1 billion. Actually, that's negative 2 to the power of 31st. Okay, so once you do this, right, you realize, yeah, okay, that's the full class name. int is a shortcut. All right, so that's how you define an array in Java. And I know some students coming from the C++ background would have the habit. If you declare an array and initialize first to what value you want, but in Java, the default is 0, so you can save one step. But it's a good habit. Okay. If you still keep initializing an array to the value you want, that's good habit. So please keep doing that one. But you have started Java in programming, then that's fine too. But keep in mind, right, doing other languages, you may have to add a 9 to initialize it. Otherwise, you may have a piece of junk or garbage in the array that you should not trust. So clear them first. Okay, so that's how you define a class, an array created. And then we're going to visit every element. So if you do this way here, this loop, you're going to access each element forward. So we're going to do j goes from 0, j less than the size or the length of the array, and increase j by 1 each iteration. So that's visit every element in forward order. You can also visit the elements backward. So start from j dot a dot length minus 1, j greater than or equal to 0, and a j minus minus. So that's how you j goes from a dot length, j greater than or equal to 0, j minus minus aj. So this will visit every element backwards. Actually, I should put this one here. For simple programs, does not matter. But for big ones, I want to recommend write a small phrase, a short sentence before a loop, before a piece of code. Tells what you want to do with this piece of code. Visit elements forward. Visit elements backward. You say, oh, I know what I'm doing here. That's true for simple programs, especially when you started from the introduction of Java or introduction to C++, that's fine. As you go deeper or higher to the USACO process, you can realize the programs will get more and more complicated. And you know what you're doing here when you write the code, but 2 weeks later, a month later, you'll come back and read your code, you would wonder, what was I trying to do here? I don't understand what, what is the purpose of this piece of code. So write a small comment. You notice, right? If you don't have the comments, the color of the code would be, say, just say the red, the blue, the black. So we call those the lines, right? We said that's spaghetti code because you don't have vegetables. So to make it healthy, you need the vegetables to green color. The same to make your code more readable. To help your reader, to help yourself, please add some healthy color, the comments. Okay, so that's to visit the elements forward, backward, and typical process or the maneuver, right, about an array would be, say, find out the sum of an array. So we can create another one here. So this, to create an array, you can do the file and, oops, that's not right. So the file menu, new, and create a class will be this one here. Or you can just create, click this button here. So it says new Java class. Okay, so I'm gonna do array sum. You don't have to check this main, but you have to type it otherwise. So if you do check it, right, the main class is already here, so you don't have to type it yourself. But don't feel afraid to type, right? This is always, I tell this class, for professional programmers, the percentage of the time for typing is about 10%. And many would ask, right? That's not true. I see those geeks, right? Computer geeks, they type so often. While they type, they also play with the pen or pencil, right? With fingers. That's true. Actually, if you consider the number of the lines they write and the number of lines they delete, why they delete certain lines? Because it's not working. So if you count the number of the lines that are working or good lines, typing will take about 10% of the time. So don't worry about this part. You say, I have to type so many lines. No, that's not the case. Actually, you have to spend much, much more time thinking and debugging. All right, so here I want to create an array and I want to find the sum. Okay, normally you're going to read from the input file. If it's USACO style, you're going to read from a file. Reading, actually, it's easy. But here I'm going to say, generate an array equals 1, 3, 5, 10, 20, 1000, 20, 20, and so on. If I want to find out, there is a question, do I share the recording? Yes, the recording will be posted to the Google Drive, and actually the Google Drive is here. Let me give you the Google Drive link. Come on. Okay. So everybody, the Google Drive is in the chat. And actually, if you click on it, it will be this one here. Actually, I have already uploaded the assignments. 2 questions there. Okay, once the class is over, the recording will also be uploaded to this address, so don't worry. Excuse me. Okay, so now if I want to find out the sum of all the elements in the array, so this is a typical technique, right? We're going to have a container. The container is called sum. Every time I see an element, I'm going to add this element to a.length here, a j++ here, right? Sum is updated by sum, the previous value of sum plus aj. All right, so from the Java introductory class, you should have learned this skill, and we're going to use this one a lot. Okay, this is one way. Another way is many times, right, you're going to see this one, sum plus equals aj here. That's fine. And actually, the two are equivalent. This 9 here and this 9 here, they do the same thing. So don't feel surprised. Okay, once you're done with the loop, you can print out the sum. And it should be here. Well, even though I just made some random numbers, and it should be there, right? This would be 3,020, that's 30, 39, yeah, 59, that's right. Okay, you're saying, right, if I want to find out the sum, that's fine. How do I find out the max value in an array? That's also easy, right? I'm going to have another container. This time I'm going to say the max value. Max value, if I say I want to start from 0, max v, I'm going to do this here. So if aj is bigger than max v, I'm going to update max v to be aj here. Okay, make sure you see the logic right. If the value is bigger than the record max value, I'm going to update it. If the aj is less than or equal to, I don't do anything. Okay, that's easy to see, right? I'm going to do max v, and of course this would be 2020. Actually, yeah, okay, that's right. For a moment, I thought this is 2021. Okay. I do write, sometimes I write in this way here. Max v is max.max, max v, and aj. Again, this 9 is same as this if statement. The number of the amount of time to perform the task, right, would be the same. Using either way would be the same. Right. So there is a little danger here. So normally when I try to find out the max value, maybe I should not use 0 as the starting value. So if you want to find the max value, you should start from the smallest one as possible. So here we're going to do the integer dot minimum value. Okay, so this will make sure we're going to get the max value. Because, right, if you start from 0, what if every element is negative? Then you will not find out the max value, the true max value in the array. So that's a safer way to do it. Or another way to do it would be, you said define max v, would be a 0 here. If max v is taken right by the first element in the array, then for sure if you run the loop, you're guaranteed to find out the true max value in the array. Okay. For USACO, this is a safe operation. Even though in APCS, sometimes this may not be safe because your input array may have no elements at all. That means the array is empty. Then you cannot access the element at position 0. So that will give it an error. But USACO, we do not focus on the case when the element, the array is empty. Rather, we're going to focus on the other opposite side. That is, when the size of the array is much, much bigger, can you still handle the calculation, the amount of the work? So normally I would recommend either to take the integer dot minimum value, or if this array is long, you can take long dot minimum value, or you can just take the a at 0 to find out the minimum value or find the max value. Okay, so I just want to put it here. These are the common operations when you work with an array. So here you're going to do the forward, backward, and you add the sum. And okay, here is one here. Actually, I need to I'll skip this one here. Let's work on this question here. Given an array of n integers, this is typical way, and find out the highest frequency of any integer appeared in the array A. Restriction, all the integers are in the range between -100 and +100, and assume the n, which is the length of A, is no more than 1000. Okay, so if you have such a question, so this would be, say, frequency. We need to create frequency. So normally you're going to read from an array, but if you're going to create this one by yourself, I'm going to show how to do this one here. So I'm going to import java.util.star, and this is also common in USACO. Why I want to do the util? Because I'm going to do the random number generator. Okay, so here I'm going to do, so int n equals, say, 1000. Here I'm going to create an array that is that has n integers. But how do I generate the n integers? Each one is in the range from -100 to +100. Normally you do this one here. I'm going to do a random number generator. Okay, you're going to learn this one when you try to find out the pattern of the numbers that you're going to see in most of the USACO problems. And then later you're going to learn how to write the USACO problems rather than just the taking or solving the problems. So change the viewpoint. You can write the program, the problems rather than just solving. Okay, this one equals new random, and this parenthesis will specify the seed. Okay, so normally you say 1, 2, 3, 4 to make it not just 1. Okay, so this random number generator will generate the integers randomly. Well, not just integers, any number you want. You can do integers, you can do decimals. Okay, but there is a seed. Once the seed is fixed, then each time the sequence of the random numbers will be determined. So this one is not actually random. It's not truly random, but it's pseudo-random. Actually, that is true for all the random number generators in computers. They're all computed using a formula. It's just how you design the formula so that the numbers you see in the output right will look like random. Okay, so here I'm going to do the j goes from 0, j less than n, j plus plus. By the way, I use the loop variable j rather than I. Why? Because sometimes I is confusing to digit 1. So now I just use j. But actually, from your experience, right, loop variables, mainly you're going to use I for iteration. Okay, so aj, I'm going to take, this would be, say, generator dot next int. Remember, right, I want to generate an integer between -100 to +100. So here I'm going to do this one, 201. So this will generate a random integer between 0 and 200 inclusive. So this will generate an integer less than 201. So this is a number between 0 and 200. But if I want to get a number between negative 100 and positive 100, that's easy. Just minus 100 here. Okay, so now I do have an array. So normally you're going to read the n integers from the input file according to USACO style, but here I don't want to read, I want to generate myself. So I have the ability to test my program myself. Okay, so now I want to find out the max frequency of integers in array A here. Okay, now right, this actually has changed, right, from negative 100 to positive 100. Okay, how do you find out the max frequency? Well, actually, I do know the numbers. Actually, there are 1,000 such integers, right? Since the range is, there are only 201 integers. Of course, some integers will be will appear more than once. Okay, but how to find out the max frequency? Okay, here is what you're going to do using the array. So I'm going to put each number between negative 100 to positive 100, right? For these 201 integers, for each one, I'm going to save the number of times it has appeared. So I'm going to do this one, build another array, so frequency, 201 here. Okay, what does this mean? Frequency x, the number of times integer x minus 100 has appeared. So if x is 0, freq 0 indicates the number of times integer negative 100 has appeared. Okay, make sure this makes sense to you. I'll pause for a moment. I define a variable frequency, the array frequency x indicates or denotes the number of times this integer x minus 100 has appeared in the array A. Okay, once this is clear, let's do this one here. J goes from 0, j less than n, j plus plus. I'm processing this variable, this integer, aj. Aj is the integer that we want to check the frequency, right? It is number between negative 100 and then positive 100. This number is actually this x minus 100, right? So I want to update frequency at the position x. So this is number that I want to process. And x minus 100 is this aj here. So that means x is actually aj plus 100. So now I'm going to update this one here. Frequency aj plus 100. So I see this integer aj, right? I've seen it one more time, so I'm going to say increase by 1. Okay, in Java, the space does not matter. I added the spaces to help you to read the code here. So I read the integer aj plus 100, that's the index in this array frequency. This location indicates aj has appeared so many times. Okay, I see it one more time, right? I'm going to increase the count by 1. Okay, now I've updated. Once I finish this loop, I've updated the counts that each integer has appeared in the array A. Now, if I want to find out max frequency. Okay, I'm going to define max frequency. Well, I know for say, I know each number, right? And the max frequency must be at least 1. So I'm going to start from 1 here. This time x goes from 0, x less than frequency dot length. So max f. Now I'm going to use this technique, right? If I want to get the max value, either I'm going to do this if statement, or I can just write in one line math.max. So here math.max, max f here, and this would be frequency at x. Once I'm done, I'm going to print the max f. Okay, so for this one, maybe a little bit hard to debug, because if I run it, it does say right 12 times is the max frequency, but you don't see the integer array A, and you don't see which number has the highest frequency. So if you want to debug, normally you're going to change this one, right? Make it smaller. So there are 10 integers, and then the range, change this one, say maybe 5 minus 2. So this will give us an integer between -2 to +2. Okay, let's run this one here. Actually, for this one, right, we can print the arrays.toString A. So this will print the elements in the array A. If you print, say, system.out.print A, that will actually print the address of A. If you want to print the content, use arrays.toString. So this will convert the content, in this case will be integers in array, to a string. Okay, let's see this one here. This array has 10 elements. There are 4 copies of 1s, 2 copies of -2, 2 copies of 2, and 2 copies of 0. So the max frequency is 4. So that's right. Okay, so using this example, I've shown here how you can generate the cases for yourself, and you can debug your own code using this way, because you have the input, you have the output, you know what to do, right? For this one, you can examine manually what is the correct answer, and then if the answer from the code agrees with your expectation, then you know your code is right. If the two do not agree, then you know somehow there is a mistake. Either your manual calculation is wrong or the code is wrong. Okay, so let's undo this part here. Oh, I should put it back. This is max f. Okay, so again, don't worry, right? All the files I wrote today in class will be uploaded to the Google Drive. Oops, time goes fast. This is about one-dimensional array, and actually you're going to do a lot with the one-dimensional arrays. And here I also want to talk about two-dimensional arrays. In Java introduction class, you probably have done a lot using one-dimensional arrays, and 2D, very similar. So I'm going to do this one, say array 2, that's actually for 2D. How do you define a two-dimensional array? Two pairs of the brackets. In this case, a equals new, and then you have to specify the dimension here. So 3 and 4. Actually, you don't have to specify this yet. If you want to create a two-dimensional array that is not rectangular shape, but if you do specify the 2 dimensions here, this will give us a rectangular array or a matrix. 3 rows, 4 columns. So Java and C++ are called row major. That means this first, the elements are arranged in rows. So you're going to do, there are 12 elements here. Where is my pen? Here. So 12 elements, 1, 2, 3, 4. So you're going to do, each row has 4 elements, and you're going to do, say, 1, 2, 3, 4. If all the elements, right, are from 1 to 12, you're going to arrange the elements in the rows, and then 5, 6, 7, 8, 9, 10, 11, and 12. When I say row major, there are languages that are column major. So they're going to fill the elements using the columns first. So for example, writing, say, Fortran, still the 12 integers, but if you do column major, you're going to do this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, and 12. Okay, so just want to mention here, sometimes if you know the difference between the two, row major or column major, you can understand the content better. All right, okay, so here. And again, right, if you want to access each element, you're going to do A, say 2 and 3. So this will access the element and the row 2 and column 3. Of course, 1D, 2D, we all use 0-based. So the first element actually is starting from row 0 or column 0. So this is actually at row 2, actually that's the 3rd row. Column 3, that's actually the 4th element in the column, in the row. The 4th element in the row. Okay, so we can, Java is complaining. So we have to put something here, so it will not complain. Okay, that's why I also love using, an IDE. In the older days, a long time ago, when you code with just something like this, all your code is have this window, right? That's much harder because even you mistyped, say, lowercase to uppercase or print, right? You must have the experience, right? Print, something like this. When you do a command window, maybe you don't realize, oh, you mistyped this one or misspelled the word, right? But using an IDE, such mistakes would, you can avoid, because the IDE will always tell you, right? When there is a red sign, always says you have a spelling error. So change this one, print. Okay, once you fix the error and then the red sign disappears, and then you can continue. Of course, right? The IDE does not help you to solve or fix all the bugs, especially the runtime error. It's impossible. But getting rid of the syntax errors also would be very helpful. Okay, if I want to access the rows row by row, you can do this one. So R goes from 0, R less than A dot length, R plus plus. Again, A dot length, this will refer to the length. Since Java is row based, so this actually will give us the number of rows. A dot length is the number of rows. And then the inner loop, I'm going to do C, stands for column. C less than how many columns? How do I recover this 4? Don't worry, I'm going to do this one. So A R dot length. Okay, AR is again an array. Actually, it is one-dimensional array. So it also has the dot length. So this one actually would be AR dot length. This is the number of columns. Okay, the number of columns at row R. Okay, and then you can say, I'm going to print out. Where is my, okay, my mouse jumped. Okay. I'm going to print, say, A at row R and column C here, and then put a space here. And if I finish this row, I'm going to have an empty line. So the out loop controls the rows, and then the in loop controls the columns. Once I finish every row, I'm going to print a empty line, a new line. So next time I'm going to start from a new line. So this will print all the elements in an array. So here, of course, right, I'm going to have 12 zeros. Okay. That's how you visit the elements row by row. And how do we access the elements column by column. That's also easy. Okay, so I'm going to put a space here again, empty line. Now, if I want to do the columns, C goes from 0, C less than, this time don't say AR because R is not defined yet, right? Let me say C is A0 dot length. Then here R goes from 0, R less than A dot length, R plus plus, A, R, C, and the space. And then I'm going to have a new line. So right, this one is kind of not very interesting. So I'm going to say assign them first. So A at R, C here, the element and the row R and the column C, I just say R plus C. Okay, so let's see the output. So here, right, these are the elements. If you do this row by row, so row 0, we have 0, 1, 2, 3. That's fine. And then 1, 2, 3, 4, and 2, 3, 4, 5. Now, if you want to print them column by column, right, I'm going to print the first column, 0, 1, 2. So first, I'm going to print out the 0, 1, 2 here. So it is here in the first process. And then we're going to do 1, 2, 3, and then the 1, 2, 3, and then 2, 3, 4, 3, 4, 5. That's how you visit the elements column by column. So these two are easy to do. But there is another way you want to visit the elements. How do you access the elements along the diagonal? Okay, many times we're going to have the situation, right, we're going to do in the exercise problem assignment. We're going to do the connect 4. Well, this one is named count 4. So connect 4, right, you have 6 rows and 7 columns. 6 rows here and then 7 columns here. And you're going to find out which player has the 4 pieces in a row or in a column or on diagonal. So how do you access the diagonals? Okay, so let's talk about the diagonal. We say the elements, this is row 0, column 0, row 0, column 1, row 0, column 2, row 3, and 4 here. And this is row 0, column, row 1, row 2, and I'm going to write one more here. And you're going to increase in the row direction and also in the column direction. Okay, notice here, when you go from the, time is going up, we'll wrap up soon here. So when you go along with the major diagonal, that is going from upper left corner down to the lower right corner, the difference along the row and the column indices would be the same. So here, along this major diagonal, the row index, column index would be the same. So this is 0, 0, 1, 1, 2, 2, 3, 3, right? But if you go this diagonal here, the column index minus the row index is always 1. That's also easy, right? You go to the right, so the column index increases by 1. You go down, the row index also increases by 1. So the difference remains the same. Okay, you notice here, right? It's always the same. That's the pattern. That's 0 here. But if you go the other direction, the anti-diagonal here, notice, right? 3, 0, 2, 1, 1, 2, 0, 3. They add up the same way. Why? Suppose you go here, right? 1, 2 here. You go southwest direction. So the row index increases by 1, but the column index decreases by 1. So sum still is the same. Okay, that's how you navigate the elements in a 2-dimensional array along the major diagonal. This one is the major diagonal direction. from the upper left corner to the lower right corner, the difference between R and C would be a constant. But if you go this untimed diagonal, the sum of R and C will remain a constant. Okay, we're going to talk more about this in the bronze class. Actually, we're going to do this a lot for bronze, silver, and up. So to visit an array, and sometimes the array may be not exactly rectangular. And here I want to mention, right? So the array can be said, this one is very long. The second row may be shorter. This one may be even shorter. This one may be much longer. This one is fine. So you can define an array of different length in each row. And we have the static way to do the row, or have a dynamic way to do the rows. So we're going to talk more about them too, using array lists of array lists. Okay, so we're going to wrap up here. So today we talked about arrays, how we're going to use arrays in Java, how to define it first, initialize it, and then how do you visit them for one-dimensional and two-dimensional. And I have given you 2 questions, assignments. One is connect for. I used the style call for. Farmer John has the cows, right? The cows are playing connect for. And another one is the Sudoku. And then the questions have been uploaded here. Each question has the problem description, that's text, and then also has the input file specification, output file, and then the sample. Very similar to the USACO style, and the same thing for Sudoku. And the test case, the same, has the 10 cases. Each case has the input and has the output. So you can run your code against the solution. If the solutions all agree with the specified output, then you got it right. If your answer does not agree with one, then you have to check what went wrong. And